Hello students, welcome to the presentation on Alkyne. First of all, let us see what are the content we are going to see in this chapter Alkyne. What is alkyne? What is the general formula for alkyne? Derive the formula for the first 10 compounds. What are the IUPAC rules to name alkyne? How to derive the IUPAC name of the first 5 compounds, and finally how to write the structural formula of the first 5 alkyne compounds. Now let us see one by one. What is alkyne? See, as we have learnt in alkane and alkene, alkyne is also a hydrocarbon. So that means it has only carbon and hydrogen in its formula. And the ratio between carbon and hydrogen should be, if number of carbons are n, then number of hydrogen should be 2n minus 2. So that should be the ratio between carbon and hydrogen. So therefore, what is an alkyne? An alkyne is a hydrocarbon in which the carbon and hydrogen ratio is n is to 2n minus 2. Now what is the general formula for alkyne? See, from the ratio we can derive the general formula. So what's the ratio we have learnt? See, actually alkyne is a hydrocarbon in which only carbon and hydrogen are present. See, only hydrogen and carbon are present. What should be the ratio? Its ratio should be n is to 2n plus 2. So what does it mean? Cn H 2n minus 2. So what this minus 2 represents? It is 2 less. Then what? 2 times the number of carbon. 2 times the number of carbon. Therefore, if you want to explain what is alkyne, alkyne is a hydrocarbon. Alkyne is a hydrocarbon in which the number of hydrogens are 2 less than 2 times the number of carbon. 2 times the number of carbon. That's it. Okay, well, let us move on to the next question. Derive the formula for the first 10 alkyne compounds. So just now we have learnt the general formula for alkyne is CnH2n minus 2. So now let us see one by one. If the number of carbon is 1, that is n is equal to 1, what will be the formula? C1H2 into 1, that is number of carbon, minus 2, that is C1H0. So therefore there is no hydrogen, therefore it cannot be a compound. Therefore alkyne with 1 carbon does not exist. When n is equal to 2, that is when the number of carbons are 2, what will be the formula? We will get C2H, 2 times 2 is 4 minus 2, that is C2, 2 into 2 4, 4 minus 2, 2, therefore C2H2. If n is equal to 3, then the formula will be C3H, 2 into 3 is 6, 6 minus 2, 4, therefore C3H4. Then what will be the formula if n is equal to 4? That is C4H, 2 into 4 is 8, 8 minus 2 is 6, C4H6. If the number of carbons are 5, then the formula will be C5H, 2 into 5 is 10, minus 2 is 8, therefore C5H8. And if the number of carbons are 6, now the formula will be C6H, 2 times 6 is 12, 12 minus 2 is 10, therefore C6H10. If the number of carbons are 7, then the formula will be C7H, 2 times 7 is 14, minus 2, 12, therefore C7H12. If the number of carbons are 8, then the formula of alkyne will be C8H, 2 into 8 minus 2, that's equal to C8H, 2 into 8 is 16, 16 minus 2 is 14, C8H14. If the number of carbons are 9, then the formula will be C9H, 2 times 9 is 18, 18 minus 2 is 16, therefore C9H16. If the number of carbons are 10, C10H, 2 into 10 is 20. 20 minus 2 is 18. Therefore, C10H18. That will be the formula. I hope now you have learned to derive the formula for the first 10 alkyne compounds using the general formula CN. The general formula CnH2n minus 2. If it is alkane, we know the formula is CnH2n plus 2. If it is alkene, the formula is CnH2n. Okay, now let's move on to the next one. What are the IUPAC rules to name alkyne? See, as already you have learned, the naming of compound by IUPAC rule has 3 steps. The first one is, first of all, we have to find out the starting name. There are certain rules for giving a starting name. Similarly, for middle name. And similarly, there are certain rules to give the end name. And then to get the IUPAC name, we have to write all the 3 names combinedly. Okay, let us see. For alkyne compounds, what are the IUPAC rules? What is the formula for alkyne? CnH2n minus 2. Therefore, if the number of carbon is 1, then the formula will be C1H2 into 1 is 2, 2 minus 2 is 0. C1H is 0. Therefore, there is no alkyne with only one carbon atom. Okay, if number of carbons are 2, then the formula will be C2H. 2 into 2 is 4. 4 minus 2 is 2. Therefore, C2H2. Now, C2H2. Okay. Now, what is the rule says? What is the starting name? Starting name depends on number of carbons. Already you have learned, if the number of carbon is 1, that is called meth. If the number of carbon is, if there is only one carbon, that is called meth. If the number of carbons are 2, then that is called eth. If the number of carbons are 3, that is called prop. Then the number of carbons are 4, that is called but. If the number of carbons are 5, then it is called pent. See, all these things we have already learned. If the number of carbons are 6, that is known as hex. If the number of carbons are 7, then it is known as hept. If the number of carbons are 8, then that is known as oct. If the number of carbons are 9, that is called non. If the number of carbons are 10, that is called tec. Already we have learned the starting name depends on number of carbon, and this is the name of each and every carbon. See, if you have not learned thoroughly already, so here is another chance for you to master these 10 names. Okay, now let us see. So in the second compound, what is the number of carbons? Number of carbons are 2. Therefore, what should be the name of the starting name of the compound? Eth. So there is no middle name for alkyne. The end name is -ine. Why? Because the name alkyne ends with the suffix -ine. That is why the IUPAC name also ends with the same suffix -ine. Therefore, the IUPAC name, if you write all the 3 combinedly, then you will get ethine. So eth plus no middle name plus end name is -ine, therefore ethine. Similarly, if the number of carbons are 3, then the formula will be C3H. 2 into 3, 6. 6 minus 2 is 4. Therefore, C3H4. If the number of carbons are 3, what is the starting name? The starting name should be prop. Then there is no middle name. The end name is always -ine for alkyne. So if you write all the 3 combinedly, you will get propyne. And similarly, if the number of carbons are 4, then what will be the formula? C4H. 2 into 4 is 8. 8 minus 2 is 6. C4H is 6. Now what is the starting name? Starting name depends on number of carbons. How many carbons are here? 4. Therefore, what should be the starting name? You would have guessed already. It should be but. And there is no middle name. And what could be the, what is the end name for alkyne? It is -ine. The last 3 letters, the suffix of alkyne, -ine. Therefore, name of this compound will be butane. Now, if the number of carbons are 5, then the formula will be C5H. 2 into 5 is 10. 10 minus 2 is 8. Therefore, C5H8. Now, what will be the starting name? The number of carbons are 5. Can you recall, if the number of carbons are 5, what is the name? It is pent. and there is no middle name, and the end name is always YNE, ine. Therefore, the IUPAC name is pentyne. Hope you understood this. Now let us go to the next 5 compounds. Same thing here. When the number of carbons are higher here, when the number of carbons are 6, what will be the formula? C6, 6 into 2, 12, 12 minus 2, 10. Therefore C6, H10. What will be the name of the starting name of the compound? The number of carbons are 6. Therefore it is hex. For 6 hex you can remember as hexagonal. So 6 angles hex. Therefore hex. And there is no middle name and the end name is ine. Therefore name of the compound will be hexyne. And similarly, if the number of carbons are 7, what will be the formula? C7. And how many hydrogens will be there? So 2 times 7 is 14. 14 minus 2 is 12. C7H12. If the number of carbons are 7, then it is called hept. Heptathlene. That means 7 evens. Hept. Heptathlene. That is an event in sports. In Olympics, women's do 7 events. So they are called heptathlene. So 7 hept. There is no middle name. And end name is ine, YNE, ine. Therefore, the IUPAC name is heptyne. And if the number of carbons are 8, then the formula will be Ce8. And how many hydrogens will be there? 2 times 8 is 16. 16 minus 2 is 14. If the number of carbons are 8, then the starting name is oct. Octopus, having 8 legs. Therefore, oct for 8. There is no middle name. The end name is same, ine. Therefore, the name of the compound will be octyne. Then, if the number of carbons are 9, then you will get C9H. 2 9s are 18. 18 minus 2, 16. And if the number of carbons are 9, it is called non. See, in physics you would have learned nonometer. Nonometer means 10 to the power minus 9. So, 9 denotes non. Okay, there is no middle name for this, and the end name is always ine. Therefore, name of the IUPAC name of this compound will be non-ine. Then, if the number of carbons are 10, then what will be the formula? C10, H will be 2 into 10, 20, 20 minus 2, 18. C10, H18. Then what will be the starting name? The number of carbons are 10. Therefore, it is dec. Dec means decathlene. You know that 10 people do 10 events in Olympics. They are called decathlene. Okay. So that's why for number 10 it is dec, and there is no middle name and the end name is ine. Therefore it is IUPAC name of this compound will be decyne. Hope you understood, and if you want you can mute this video, or you can pause this video and you can try to recall and write on your own in your notebook before proceeding to the next slide. Now, how to write the structural formula of the first 5 alkyne compounds? Again, it's so simple like alkyne and alkene, and let us see one by one. If the number of carbons are 1, see already we have learned there is no alkyne compound with only 1 carbon. C1, H, 2 into 1, 2, 2 minus 2 is 0, therefore C1, H is 0, that is C. So it's not a compound. Therefore, alkyne with 1 carbon does not exist. If the number of carbons are 2, then the formula will be C2, H2 into 2, 4, 2 into 2, 4, 4 minus 2 is 2. Therefore, C2, H2. How to write the structural formula of this? First, you write the number of carbons side by side, adjacent to each other. Connect these 2 carbon atoms by means of a triple bond. Alkyne means it should have a triple bond between 2 carbon atoms. Now we have to fill up the valencies by counting the number of bonds already present in each and every carbon. See here, for this carbon only 3 bonds are there. It requires 1 more because its valency is 4. Therefore it should have 4 bonds surrounding each and every atom of carbon. And for this carbon also 3 bonds are there. It requires 1 more. Now fill up these bonds with hydrogen atom. So now you will get 2 hydrogen atoms and 2 carbon atoms, 1 and 2. So the formula is C2H2. Now if the number of carbons are 3, what will be the formula? So here C3 H, 2 into 3 is 6, 6 minus 2 is 4. Therefore, we will get C3H4. Now, how will you write the structural formula? First, you write all the 3 carbons adjacent to each other, that is side by side. Now, connect any 2 carbon atoms by means of a triple bond. It can be either here or here, anywhere. So, let me take here 1, 2, 3. All the other bonds between carbon and carbon should be a single bond, no double bond. In alkane only triple bond and other bonds are single bond. Only one place there should be a triple bond, all other bonds should be a single bond. Now again you count the number of bonds surrounding each and every carbon atom and make it 4. So for this carbon only one bond is there. How many more required? 3 more required. For this carbon 1 is here and 3 bonds are here. See, already 4 valencies are 4 bonds are there. Therefore all the 4 valencies are satisfied. Therefore no more bond is required for this carbon. Now let us take this carbon, 3 bonds are there and it requires 1 more. So put here. Now fill up all these bonds with hydrogen atom. 1, 2, 3 and 4. That's it. So now the formula is C3H4. 1, 2, 3 carbons. Then 1, 2, 3 and 4 hydrogen. So C3H4. If you condense this formula, you will get, see this carbon, this carbon here, it is bonded to 3 hydrogen atoms. Therefore you write CH3. Then this single bond comes here exactly. Now write down this carbon. Now put down this 3, that is the triple bond here, and put down this carbon here, and this carbon is bonded to this hydrogen. So this is the condensed formula of propyne. So 3 carbons, therefore the name is prop. Since it is having a triple bond, it is propyne. Okay, now let us take, if n is equal to 4, if the number of carbons are 4, how to write the structural formula? What will be the formula? First of all, C4H, 2 into 4 8, 8 minus 2 is 6. Therefore C4H is 6 is a formula. Now how to write the structural formula? 1, 2, 3, 4 carbons. Write all the 4 carbons adjacent to each other, that is side by side. Put a double bond between any 2 carbon atoms anywhere, but only in one place. So let me put it here. It can be here or here or here, anywhere. It doesn't matter. Then connect all the other carbon atoms by means of a single bond. Remember, after one triple bond, it should be all single bond. There is no double bond. Never ever get confused with that. Now you fill up the bonds of each and every carbon atom according to the valency. Valency of carbon is 4. Therefore it should have 4 bonds surrounding it. But here only 1 is there. How many more required? 3 more. 1, 2, 3. And for this carbon 1 here and 3 are here. So 1 plus 3, 4. Therefore this is already satisfied with 4 bonds. And take this carbon, 3 bonds are here and 1 bond is here. Altogether 4 bonds are there. Therefore all the 4 valencies are satisfied for this carbon also. Now let us take this carbon, only 1 bond is there. How many more required? 3 more. So 1, 2, 3. Fill up all these bonds with hydrogen. 1, 2, 3, 4, 5 and 6. Okay. So now if you condense this formula, you will get CH3, single bond C, triple bond C, single bond CH3. Hope you understood how we are getting the condensed formula. See here, this carbon you are writing here. This is bonded to 3 hydrogen atoms. That all 3 put together you are writing it here. And this carbon here. And this single bond here. And the triple bond here. And this carbon here. And this single bond here. And this carbon straight down here. And then it is connected to 3 hydrogen atoms. 1, 2, 3. And all the 3 hydrogens put together here. It's so simple if we understand the basic concept. Now let us see the last compound when number of carbons are 5. What will be the formula? C5. Number of hydrogens will be 5 into 2, 10. 10 minus 2, 8. C5H8. Now let us put all the 5 carbons side by side. 1, 2, 3, 4, 5. Put a triple bond only in one place between any 2 carbon atoms. So let us say here we are putting it here. All the other bonds between carbon and carbon should be a single bond. Now count the number of bonds for each and every carbon and make it 4. For example here, this carbon only 3 bonds are there, so it requires 1 more. And for this carbon, here 3, here 1, 4, already 4 are there, therefore it doesn't require any more. For this carbon, 1 this side and 1 on the other side, it requires 2 more. For this carbon, 1 plus 1, 2 are there, therefore this also requires 2 more. For this carbon, only 1 is there, so it requires 3 more. 1, 2, 3. And fill all the bonds with hydrogen. 1, 2, 3, 4, 5, 6, 7 and 8. Now this is the structural formula for alkyne having 5 carbon. If you condense this, what will you get? CH, triple bond, C, single bond, CH2, single bond, CH2, single bond, CH3. Hope you know how to do it now exactly from the structural formula, how we can condense and write. This carbon here, this is bonded to one hydrogen, therefore I have written it here. And this triple bond exactly here. This carbon is here, it is having no hydrogen, and this is bonded to this carbon here. This is indirectly again bonded to 2 hydrogen atoms that I have written together here, and this single bond comes here, and this carbon is here, and this is bonded to 1 plus 1, 2 hydrogen that I have written them together here, and this single bond is here, and this carbon is here, and this is bonded to 3 carbon atoms, 1, 2, 3. I have written all the 3 together here. Hope you understood how to write the structural formula of alkyne also. Now let us see, let us take the recap of what we have learned in this chapter. What is the first one? What is alkyne? What is alkyne? Alkyne is already we have seen, it is a hydrocarbon containing only carbon and hydrogen. In carbon and hydrogen ratio should be N is to 2N minus 2. And what is the general formula for alkyne? See, from this definition we can easily get the general formula for alkene. What is it? Cn H2n minus 2. What is the meaning of this formula? So N is number of carbon. Therefore the alkyne is a hydrocarbon in which the number of hydrogen should be 2 less than twice the number of carbon atom. So that is what is the definition of alkyne. Then derive the formula for the first 10 compounds. See, already we have learned the general formula is Cn H2n minus 2. So you know, if the number of carbons are 1, the number of hydrogen will be 0. Therefore this compound cannot exist. If the number of carbons are 2, the number of hydrogen will be 2 into 2, 4. 4 minus 2 is 2, C2H2. If the number of carbons are 3, the number of hydrogens will be 2 times 3 is 6, 6 minus 2, 4. If the number of carbons are 4, number of hydrogens will be 4 times 2 is 8, 8 minus 2 is 6. If the number of carbons are 5, we know the number of hydrogens will be 5 into 2, 10, 10 minus 2, 8. If the number of carbons are 6, then C6, 6 into 2, 12, 12 minus 2, 10. If the number of carbons are 7, number of hydrogens will be 7 into 2, 14, 14 minus 2 is 12. If the number of carbons are 8, then the hydrogens will be 2 into 8, 16, 16 minus 2, 14. If the number of carbons are 9, number of hydrogens will be 2 into 9, 18, 18 minus 2, 16. If the number of carbons are 10, H 10 into 2 is 20, 20 minus 2 is 18. So we have to multiply the number of carbon atoms by 2 and then subtract by 2. Then what is the IUPAC rules to name the alkyne? Already we have learned it has got 3 steps. First we have to find out the starting name. Then the middle name. Then the last one we have to learn the end name. Starting name plus middle name plus end name. And already we have learned starting name depends on number of carbons. Middle name, there is no middle name. The end name is ine. See, already you have learned number of carbons and its name. 1 meat, then 2 eat, 3 prop, 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 is dec. See, already we have learned, so it is another chance for you to master it if you have not already mastered them. And now let's move on to the next one. How to derive the IUPAC name for the first 5 compounds. See, already we have seen it, and quickly we will review it. What is the first compound formula? First compound C1H0, therefore it does not exist. If it is C2H2, if the number of carbons are 2, it is eth, then there is no middle name, then the end name is yne, therefore it is ethyne. And similarly, if the number of carbons are 3, then the formula will be C3, 3 into 2, 6, 6 minus 2, 4. So then it will be prop, there is no middle name, then the end name is yne, therefore the name will be propyne. Then if the number of carbons are 4, C4H, 4 into 2, 8, 8 minus 2 is 6. Number of carbons are 4, therefore the name will be bute. There is no middle name, plus the end name is yne, therefore the name will be butane. Then if the number of carbons are 5, then 5 into 2, 10, 10 minus 2, 8. If the number of carbons are 5, starting name is pent, then there is no middle name, the end name is always yne, therefore name of this compound will be pentyne. So like that you can derive up to 10 compounds yourself. Then what is the last one? How to write the structural formula of the first 5 alkene compounds. See, just now we have learned all those things in the previous slide. And if you want, you can go back to the previous slide and then you can learn it very thoroughly, and then stop the video and then you try to recall and write in your notebook yourself. Hope you have learned a lot today in Alkyne. That's it for the day. Thanks for listening.